Hi, I'm Scott Hanselman. This is another episode of Hansel Minutes. Today I'm chatting with Dr. Martin de Bock. He's an associate professor at the University of Otago in Aotearoa, New Zealand, and he's a pediatric endocrinologist. How are you, sir?
Good, thank you, Scott, and thanks for welcoming me on today.
No, this is great. I've been looking forward to chatting with you. You've done a lot of really, really interesting work in the diabetes space, and you seem to be very kind of unafraid to try new things and interesting things. You've worked with Dana Lewis, who is largely considered to be the godmother of the open source artificial pancreas movement. I myself am a looper. We call ourselves looper because I have a closed loop open source artificial pancreas myself. And I've had Dana on the show, and I encourage folks to listen to the episode that we had with her and others. But you've worked and been promoting the idea that an insulin pump, which can cost as much as $6,000-7,000 US today, really shouldn't. You should be able to make your own, and that's such a scary and exciting idea. Talk to me about all the different people that were involved and how they had that idea.
Yeah, all right. So it really came born when I arrived back in Aotearoa, New Zealand in 2018, where there's a professor here at the University of Canterbury, a mechanical engineer, Jeff Chase. I knew he'd been doing a lot of work in the diabetes space for quite some time and was really looking for a clinical champion. So I went over and saw him and went up in his office, and we started talking about building hardware and how this could really revolutionize access for people if they're really expensive. And keeping in mind that, of course, the material cost you pay for a pump is very different than a commercial cost for lots of reasons we can talk about if we need to. And we started talking about it, and he goes straight away, he said, well, I'm not going to go in this unless we make it for 100th of the price. Like it was immediately straight out. Don't want to make money out of it, and no point in doing this unless it's 100th of the price. I was like, okay, all right. So he's got an army of PhD students, and then we went down this pathway of making this LEAP program, or low cost pump sort of pathway for type 1 diabetes. We've got a large national grant, New Zealand Science Challenge grant, that bankrolled this development of this whole space of creating access for more people. And it was not only just building a hardware system, but also lots of sort of qualitative work with healthcare professionals and people with type 1 to figure out what people's tolerability is around this concept of a non-commercially backed glossy brochured product. If it were to come there, what are the challenges and specific issues going to, because it's a very complex area.
Yeah. As a diabetic myself now for over 32 years, there is always this sense that no one's going to care about my diabetes more than me. While there are doctors like yourself who care, there's the medical community, there are researchers that care. There is always this sense of being alone and needing to take kind of control. I like to joke that on The Walking Dead, when the zombies come, the diabetics usually get eaten first because we need the big machine to make insulin. We need it to make durable medical equipment. So the idea that one could take control of their diabetes with do-it-yourself things is interesting. However, for many, many years, I just took shots. Why is time and range important? And why can't we all, quote, just take shots?
Oh, that's super important. Great question. And there's so much evidence now behind that. Automation beyond injections gives you healthy glucose levels without burden. And that's the key thing, really. I mean, everybody, even on shots, not everybody, but a lot of people could achieve, a healthy HbA1c within target using shots, but you'd have to live a very restrictive life. And then you're sort of bargaining for your quality of life versus quantity, right? So let's remove that bargaining. Let's have both. Which is what automation has really done in the space. While we wait for the very smart immunologists to come up with that solution for us, that will be the real cure. We have a technology cure to a degree where we can get healthy glycemia that allows for long-term longevity with type 1 diabetes by attaining healthy glycemia without burden or reduced burden anyway.
So for those that are listening who are not diabetic, who may not understand, the analogy I usually use is like staying in the lane on the freeway. And you've got people claiming to have auto-driving cars, but they're really just kind of line followers. They know how to stay in the lane. And there are algorithms now that can help diabetics stay in the lane. They're not complete self-driving cars, but they'll at least kind of like notice you floating out of the lane and floating back in. And is that a good analogy? Does that make sense?
Absolutely. I've used that same metaphor a lot. And it's very similar where the car engine is your insulin pump. That's what's driving things along. The car's sensors are the continuous glucose monitor that you have as a person with diabetes that is measuring if you're going to go outside those lanes. And then they feed together with an algorithm or computer program, which would be your chip and your fancy electronic car that does the auto correcting. And with a car, it's that auto steering back in or the vibrating steering wheel, whichever, it depends on which model of electric car or self-driving car you have, but very similar. Absolutely. It's a great metaphor and very understandable.
Yeah. And when you're driving a car and you're trying to stay in the lane, you're not realizing that you're making tiny little adjustments every few minutes. But if you take a shot or you are controlling your diabetes with shots and food, shots bring your blood sugar down, food makes it go up. You tend to be making big moves, big jerky moves as you take a shot, eat a bunch of food. What does an insulin pump do to make that less jerky?
Yeah, it's really good. There's nice data to say that for a person living with type 1, you're making over 100 health-related decisions a day just to try and stay in the lane, right? And that's unsustainable. So you get this term that we call diabetes burnout. Classically happens after a couple of years of type 1, but can happen anytime in someone's life. And it's episodic. Even with people who are really well controlled and sustain it for a long time will go through periods of just being against the wall and being really fatigued by the constant decision-making process. In my opinion, I don't have the self-acknowledgement. I don't have type 1, so I don't have a lived experience. So it's really important for me to acknowledge that I can't share that feeling of those constant decisions. But what I can see objectively is that when you take micro decisions away from somebody, it frees up the rest of their mind to deal with whatever else is going in their life to make it easier. So that might be easier decisions around making healthy nutrition choices or easier decisions about exercise or their jobs or whatever else is going on in the world if you're not micromanaging type 1 or opposite, giving up and then letting your glycemia dictate the way that your life is led. So trusting into a system like that, we can talk about that if we need to, but algorithms definitely are better at doing that on a micro time zone than our own human brain, just because we've got so many other things that prioritize that.
Yeah, that is extremely true. I haven't had a formal burnout, but I refer to the psychic weight of the diabetes pressing down on you. Since I'm a programmer in my day job, the analogy I usually give is opening up like Task Manager on your computer and going, "Hey, what's using up 20% of my CPU?" Well, that's diabetes, and you can't, So I only have 80% of my CPU available to live, while you may have more. But all the different things in your life that equal the stress of the pie chart of your existence. When you unpack all of your privileges and try to figure out how much overhead do you have, I'd really love to have a little more.
Yeah, and if I may, just let me digress for a moment. Like when I see a lot of, I'm a pediatric endocrinologist, I mainly see young people with type 1. I see teenagers who maybe might be struggling, right? And then I talked about how to motivate people on a day-to-day basis because long-term complications aren't a good motivator. We never use it. And about how to be your own person. And I often talk about, people when they're 16, 17 care about what people think of them, right? So I create this hypothetical situation. So let's say you're applying for a job and you're a Johnny and you've got type 1 diabetes and your A1C is awesome. So your glycemia is great. And then you've got Jeremy, he's got the same CV as you. Everything looks the same. Everything's the same, but he doesn't have type 1 diabetes. And they say, which one will I employ? And they usually go, oh, the guy without diabetes. I said, well, no, actually, I'll employ the guy with diabetes because you've had it way harder. Jeremy had it easy to get his CV. Like, you don't need to wear it as a badge of honor, but it's a recognition of how much work and how much, I guess, organization, how much of you look after yourself and those sorts of character traits that you can express in a job or in a relationship or anything. And sometimes that sinks in as a motivational tool to say, look, if you improve your glycemia, do a little bit more work, how it can open things up for you rather than having doors closed as a young person. Keep your life open.
Yeah, it does feel like living life on hard mode or at least medium mode sometimes.
Yes.
There are days when it really takes a lot out of you.
Yep. And this is what this whole automation is about. Let's minimize those days and minimize those micro decisions.
Right. So we talk about time and range, and you're talking about one's, glycemia, one's management of the sugar, again, to try to make sure that the normally sugared, the muggles that may be listening, understand what we're talking about. We're trying, and correct me if I'm wrong, to simulate having a working pancreas. People are always telling me I should, take cinnamon or eat chocolate or do, Ayurvedic yoga. I have a non-working pancreas, correct? It is a vestigial organ that is doing very little for me right now.
Yeah. Yeah. Well, let's be more specific. The beta cell. Okay. So the pancreas does many things, but in type 1 diabetes, the beta cell, which makes insulin, and it's only one component of glucose metabolism, but a really like one of the majorest, obviously, strongest influence on, especially after you've eaten. So we're trying to simulate what that beta cell that you no longer have does. So your glucose goes up in the person without diabetes, your beta cell sees that, or sees that increased glucose delivery to the bloodstream from the food you've eaten, carbohydrates specifically, and produces more insulin to try and stop that glucose from going so high. And it's super interesting. That whole insulin mechanism around energy and glucose metabolism is highly preserved through all of evolution, actually. Some of the simplest bacterial organisms that have a very similar like pathway. So it's such a crucial part of being alive and living on this planet. So it's something you can't meddle with, and you need to be replacing it because there's no other solution. Cinnamon isn't going to fix this, unfortunately.
Yeah, everything that I eat, whether I eat sugar or I eat meat, it's going to turn into glucose at some point, and it's going to enter the bloodstream. And if I don't get it out of the bloodstream, I'm effectively marinating in my own sugar, and all kinds of bad things happen at that point.
Yeah, it's like swimming through maple syrup, right? It's pretty tricky.
Yeah, and it feels like that too, of course. So then I need, and a type 1 diabetic needs, and is the word exogenous insulin, external insulin?
Yeah, exogenous, so insulin from the out. Yeah, it might be different if you're, I don't know, if Americans.
I don't know, aluminium and all that, right?
We call it exogenous in New Zealand, which just means from the outside. Yeah, and we can't use it, unfortunately, we can't take it as a pill, we can't rub it on as a cream. It has to be injected into the subcutaneous tissue. That's the fat tissue just under your skin. And you can do that with injections, which we've talked about, but also through insulin pumps where the little infusion cannula just goes underneath the skin, typically worn on the abdomen.
Okay. And we don't have, I don't carry an IV. I don't have this in my veins because that would be problematic to walk around with this IV. But we can have a hole in ourselves, at least in the fat, with this little plastic cannula. Why is one okay and one is not?
Because the human body's really good at getting rid of stuff that's not in it, right? Or shouldn't be in it. And blood vessels particularly. And also your best immune thing that you have on your body is your skin, right? So if you create a hole in it, you break your immune system. If that hole goes all the way through the bloodstream, you have a risk of inducing infection into the bloodstream and also creating clots in that bloodstream, which is why if you've ever been to hospital for an IV drip or an IV cannula, they only last a day or so and they're being replaced and often get infected, red and inflamed. If any of your listeners have experienced an IV line, usually it's not just a simple thing that lasts for as long as you need it. It needs to be very carefully managed. So
right.
Intravenous, it would solve a lot of problems in terms of how we have it, how fast insulin works, but it's not a sustainable way to give insulin because of those risks.
Okay. So then you have an insulin pump, which has a cannula, which is kind of like a needle, but it's a little plastic piece that is left in.
Or steel. Yeah, or steel. Can be steel or plastic. The steel is a really tiny little thing. You don't feel it. Yep.
And then this is sitting in your body. And I've had my insulin pumps on earlier versions for 7 to 10 days without any issues. I currently use a pump called an Omnipod for 3 to 4 days with no issues. But that piece, though, that plastic cannula and the tubing that is going to be sterile, that's a piece of replaceable, and I have to throw it away. If I'm going to start printing or creating my own insulin pump, are there going to be pieces I'm going to have to throw away and replace? And how am I going to deal with that?
Yeah, absolutely. So you need a system that will, I guess, use either a commercial product that you decide to put on your block as an insulin pump that you've created, and certainly those that is possible. It's insulin pumps generally, if you don't count a patch pump which you're using, are just syringe drivers effectively. Some of them are a little bit more complex in terms of the machinery they use, but you're just pushing a plunger down, and so that system is pretty generic, really. So of a syringe driving device.
Okay, so that's a good thing to understand for folks to visualize. Since this is an audio podcast, you're pushing against a syringe that is a plunger, and that plunger, though, it needs to be done at sub-millimeter, very, very accurate type stuff. And if it gets bumped or if it doesn't, you could cause some real serious issues if you overdosed someone on insulin. You'd give them at the very least a bad day.
Yeah. So absolutely. So you create robust hardware around that, and you have an engine that allows accurate delivery. And so that's important if you're thinking about developing the systems, that you test that and you test its accuracy against standards either set by other pumps, or actually there are international standards for these kinds of systems about what level of accuracy you need for it to be used as a health delivering, device.
Yeah. Now, I realize that you're not an engineer. You partnered with an engineer and with a set of PhD students in engineering. But it does seem like in the last, 5 or 10 years, like quality of stepper motors, gearboxes, being able to purchase a motor, in this case, you have one that you get from China that really can perform for many, many, many years at an incredibly high accuracy. I don't think we could have done that 20 or 30 years ago. Something happened in the last few years. I wonder if it was 3D printers that made that possible.
Yeah, who knows? I do not have the expertise or the industry knowledge to know what that evolutionary step was in terms of hardware manufacturing. But there's another point to this that you allude to, for example, about its longevity. Longevity would be an issue if you have a machine that costs you $15,000 or $10,000. But if your machine costs you $80 and your longevity lasts shorter, it's less of an emotional tie to an expensive unit. You're more forgiving of something, the cheaper it is. So you need to find if you're a person dealing with machinery, it's like going to the hardware store, right? If you buy a drill set, if you go and get the cheapest one off the shelf, you have an expectation that, okay, this might only last for 6 or 8 months, but that's okay because I can grab another one. Or you can go to the most expensive one that's got all its thing and maybe that will last longer. And that's a very personalized choice about what you do. Or it might be a factor of your current financial situation, which takes in a whole different meaning of personalized care in terms of what your current situation is, which is a really interesting concept.
That is a really great point to call out because, I'm going to feel one way about a $30 Android phone that I get at Walmart versus the latest and most fancy iPhone. And if I'm a child, because you're involved in pediatric endocrinology, I might be concerned that I'm going to put a $6,000 insulin pump, in a pocket pouch on a 5-year-old and send them off into under the ocean.
Oh, yeah. The best thing you're doing is ringing your insurance company, right? And figuring out what your insurance policy is, should you be the one at fault for destroying your pump. I mean, obviously, commercial pumps they're pretty industrial strength. It's pretty hard to smash them, but we see smashed pumps regularly.
Yeah. So access has been super important, and you have actually done studies across folks in New Zealand that have different races, different economic environments, and have found that folks that have less access have less health outcomes, like they have negative health outcomes.
Yeah, and that's seen globally. And what's interesting, we did one step further. We took a cross-sectional status of all the people living in New Zealand and saw those who were using technology and not technology, and found that it was a great equalizer. So the disparity you're seeing between low socioeconomic status and high socioeconomic status, or by ethnicity, often minorities have lower socioeconomic status and poorer outcomes. You see that difference ameliorated quite considerably. Actually, for our ethnic minority, our most important and our founding, native indigenous population in New Zealand, Māori, we found that CGM, for example, on its own, which is continuous glucose monitoring, removes the difference that would be predicted on socioeconomic status or by ethnicity. That's a really important issue to get out. Access is so important and something that needs to be, it's a global problem that needs to be sorted.
Yeah, CGMs, continuous glucose meters, the idea that I don't have to prick my finger. I used to prick my fingers, 10, 15 times a day, knowing full well that each time I pricked my finger, it was costing me $1.
Yes.
Like that was significant. And there are those still to this day who ration their finger sticks because they know it's $1 every time. CGMs can check your blood sugar via interstitial fluid every 5 minutes, and it's huge. It is an absolute game changer, but it's largely only available in Australia, New Zealand, and then the Northern Hemisphere.
Yes, absolutely. So that's a problem, but it's a problem that luckily, well, hopefully in technology, which is slightly different than pharmaceuticals, is that technology, as it becomes created en masse, it tends to drive prices down, where we don't see that in pharmacology unless you come off patent and come into generics, which takes a long time. We're seeing increasing competition in the CGM market. A lot of startups coming in from China and from South Korea, for example, great technology manufacturing power heavyweights that are entering this market with much lower cost just as long wearable. They last between 10 to 14 days, for example, and great accuracy. And the true test is when they become more marketable access or wider to see if people like them or not, or whether they're accurate enough. You can only believe so much you see until you've actually had a patient in front of you with it on. But I think that we will see finger pricking as something that will be like urine glucose testing of the past. It really is the hope, because the CGM price will come down to a point where it's competing directly with a disposable strip.
Mm-hmm. So you think that's happening now? We're in the middle of that being driven to nothing.
It's already there, like in health systems where CGM is fully funded. You're thinking of countries like Australia and New Zealand's about to become that. Some of the Scandinavian countries, for confirmation, if you're not happy about the CGM reading or there's some inaccuracy that you're concerned about, but generally speaking, they are seen as not requiring finger pricking. I never say no CGM is ever that, but, a little bit of finger pricking compared to, like, as you said, 8-10 times a day to get healthy, do that.
So access in the Southern Hemisphere, when I say the Southern Hemisphere, I'm of course talking about South America, Africa, parts of Asia. We still see people getting diagnosed. They get handed syringes, a vial of insulin, maybe pens, and finger pricking, and they're sent on their way. Can they live long and healthy lives?
Generally speaking, no. It's heartbreaking, isn't it? That your health outcome is dictated by where you live and the socioeconomic status of the nation you live. And you could put any health condition in that bucket, and type 1 is one of those. And it's really sad. And, you can see it at a local level, like I'll at a clinic. So currently we don't have CGM funded, but it's coming. We basically have haves and have-nots. We have everybody walks in with their CGM and is an automated system. Their glycemia is awesome. Their HbA1c are great. And then we have the rest that come in who don't. And it's that obvious. And it's dictated completely by socioeconomic status, which is just sad.
Yeah. Another thing that I think is so insidious about diabetes is that when I give my presentations on it and I talk about how who would design such a disease where people who are good at math live longer than people who are less good at math? Like, what an evil disease to design.
Yeah. Absolutely. I often say that the people with type 1 who live longest are accountants. They like things in rows and columns, and type 1 likes things in rows and columns, and very consistent. And that's what I was talking about earlier at the start about the burden and the restrictiveness, that if you're on a simple way, I could call it simple, I guess, the traditional injections and intermittent finger pricks, you have to live a very restricted life to have a healthy glycemia.
Yeah. Now, 8 years ago, when I started looping, when Dana and her husband Scott met with me and showed me the very beginnings of what would become Open APS, the Open Artificial Pancreas System that they had designed, most practitioners, most doctors, and you're a practicing pediatric endocrinologist, if someone came in and said, I'm going to put my kid on some Python scripts and they're going to carry a Raspberry Pi around in a little backpack, sounds like a plan, right? It would be fair to say you'd probably be against that 8 to 10 years ago.
This is interesting because I think that it depends on the healthcare professional that you're seeing. So there are a few healthcare professionals who have, I guess, a different view than that. Like the tricky thing is we live in a highly regulated healthcare system where what we're allowed to do and not to do is often dictated by health regulatory bodies and not by the person in front of you. So you have to have a comfort level, but also be willing to, one, educate yourself around what they're using, be willing to learn. And secondly, know enough to be able to have an educated conversation with the person around the pros and cons of what you're going through, and be very good at documenting. There's consensus statements that are now published and available. So if you're listening and you're a healthcare professional wondering how to navigate this process in a way within your own health regulatory framework, there's very good documentation on that. And if we need to, we can pop a link up somewhere on your podcast through that if you're a healthcare professional listening, about how you might navigate that.
Yeah, absolutely. And it's also worth saying that Dana and folks like her have really championed putting data behind these things. This isn't just a bunch of weirdos writing a for loop. This is really formal and has been proven that these algorithms are now better than me at calculating how much insulin that I need. So effectively what you all are asking me to do is to let go of the wheel and let the car drive itself, which is a very nerve-wracking feeling.
Yeah. And we all watched Space Odyssey, didn't we? And we don't want to be locked out of the podcast. We don't want to ask Hal to open the pod bay door, do we? So we have this distrust of technology that it's going to fail us. And that's healthy. We need some ability to critique it. But we also have a lack of forgiveness for technology if it doesn't deliver what you want it to do. To set expectations is very important as a healthcare professional, that no system is going to be 100% foolproof. It's not going to cure your type 1, that you are hands-free, just like you said.
Yeah.
So that's a really important disclosure around this whole point.
I've had in 8 years of looping, one or two that I can think of moments where, to use our analogy, the car swerved suddenly in an unusual direction. And because it's open source, I was able to log the bugs and have the bugs fixed for people downstream. But I've certainly made more than one or two errors myself in 8 years. So certainly the argument is that it's better than a human. And the risk is letting me do the work, right?
It's really interesting because we're quite able to forgive our own misgivings, our own mistakes. I shouldn't have eaten that, or I should have drunk it, man. I've had a bit of a blowout, my glucose level. Oh, well, ho-hum, life goes on. But if you do everything right and the code or the technology, or you get an infusion set failure or something, you get really frustrated because you've done everything you need to do in your own capacity to keep in the lane, if you like, and you've been let down by hardware. So as healthcare professionals, we spend a lot of time educating around how you troubleshoot if you leave the lane and how you keep yourself safe.
Yeah, it very much is a disease that requires one to give themselves a little grace, even though we are told to be in range 80%, 90% of the time, and really try to pretend that we're not diabetic. You're going to have lousy days. I know I had a lousy day yesterday.
Yeah, absolutely. There are so many, so coming back to that pancreas thing and glucose, what we talked about at the start, the glucose metabolism is not just a simple eating an insulin equation. There are so many other things that affect your way your insulin works, or how your glucose is absorbed or metabolized by the rest of the organs in your body, including your liver and your muscle. And we haven't even begun talking about exercise, which is still, I think, the greatest challenge in type 1 diabetes.
It's funny that you mentioned that, because I feel like, let me give you this. I just got back from Spain, where I went with my son, and you can see my pedometer app on my phone go from, 6 to 10,000 on a regular day to 25,000, 30,000 steps. I was walking 10, 15 miles a day. My blood sugar was amazing, which apparently means if I just walk 16 waking hours a day, I could eat anything and do anything I want, but I just can't.
There's a really good case study on that. When you look at the guys in the, I don't know if you've heard about the Team Novo, the cyclists.
Yep, Team Type 1.
Yeah, so, and hardly any of them are on pumps, actually. They're all on just a little bit of basal insulin because they just burn up all their glucose metabolism because they spend every day on a bike just fueling up. And that's what we need to remember, that so much of your glucose disposable is what I call insulin independent. And the more fit you are, the more efficient that is. So that's why we spend a lot of time at diagnosis, actually in clinics, talking to people about lifestyle as well. That doesn't change whatever type the diabetes you have. Lifestyle is a super important aspect to the way you live life for everybody, but diabetic or non-diabetic. That's a very good comment for anyone.
Yeah, certainly I don't want to make anyone feel guilty, and I want to make sure that folks that are listening understand that type 1 and type 2 are so different that they might even not be called diabetes. They're such different diseases.
Yes.
But movement, what do they say? Motion is lotion. Just keep moving the body, and the body will help you figure these things out to the best of your ability. I always tell people when they're diagnosed, the number one thing you can do is don't eat and then just plop on the couch. Go for a walk after dinner. Don't just eat and then sit, because you're telling your body that you're not moving, and then you're just going to store all of that. And that's where highs happen.
Yeah, absolutely.
So how can someone learn more about this? Certainly they can go Googling around. They can find your website at the Otago website. You've written extensively on this and been involved in a number of different papers, including that CREATE trial with Dana Lewis. And then Matthew Payne and the others have that design of an open source, ultra low cost insulin pump at Hardware X. We'll put links to all of this. But should I go right now after we get off of this call and make an insulin pump here in my house?
That's super interesting and a challenging question. We're about to publish a study where we built these pumps and put them on people. It's just under production now. So maybe by the time this is broadcast, it will be available for you. It will be open source in terms of anybody can reach that paper. Anything you do in the space is obviously your own risk. It's not been thoroughly tested. It hasn't been real life tested in terms of the normal crashing and bashing of daily life. So I would err on the side of caution. Out of interest, build one, let it make some insulin, put it into something else rather than yourself for a bit, get a feel for it, and be interested in the process around it. I guess is fascinating. I don't think we're there for people to just go and build it yourself and put it on yourself at this point. We still need to iron out everything regarding the safety of something like that.
It is amazing, though, that it is happening and that it's the possibility, like the door has been opened. When I was diagnosed, ultra fast and ultra rapid insulins didn't exist. Before that, people were boiling their needles and using pig insulin. So many, many things have happened. We always joke that diabetes will be healed and cured in 5 years. That's probably not going to happen, but we may solve this thing with software and hardware, and hopefully it'll be open source.
Yeah, another interesting thing about cure, right? Well, how do you define cure? So, and I talk a lot about with families around that. If you're in the oncology field or cancer field, cure is defined as living beyond 5 years from diagnosis, right? So, with that respect, we have cured type 1. What we're now doing is saying, okay, well, how do we make sure that life is as good as everybody without type 1? So it's about expectations and mindset again, around how we have those conversations. So yes, of course, Holy Grail is we'll find a beta cell that will do the job, that will hide from your immune system. That's what's caused you type 1. And that might be some way away, but for the moment, you use technology, which we're really good at, and can hide from a very good at immune systems, because humans live on this planet because we've got an awesome immune system, and you don't want to suppress that. So in the meantime, let's embrace technology. Let's make it accessible for everybody, so that we don't have the haves and the have-nots in the space for people with type 1.
Yeah, that cannot be overstated, how lucky I feel that I will probably die of old age. And that's what we want everyone to have, that privilege to die of old age and not die of diabetes if diabetes doesn't catch up with me.
Yeah, absolutely. That's what we're all in this game for, and it's not really a game actually. It's what we do. What wakes me up in the morning is this is not a rare condition. It's global. It's non-selective, and that means this is not something you choose to have during lifestyle or not. It affects all walks of life, all around the world, and all ethnicities. And so, if we can make this better and healthier, and while we're waiting for a real cure, if you like, let's get on this.
Brilliant. Thank you so much for chatting with me today.
Oh, you're welcome. It's been a pleasure, and please reach out, anybody out there, if you want to talk more about it. And just a big shout out, of course, to Dana Lewis, who you've had on this podcast series previously, who really, with her "We Are Not Waiting" moniker, is really what this is all about. We're not waiting for people to find a solution. We're going to find the solution because we've got the lived experience, and we'll get on with things. And that's still true today.
Fantastic. This has been another episode of Hansel Minutes, and we'll see you again next week.